Hello and welcome to the final episode of the Series 2 Power On series. In this episode we will be going through each step of our test flow and covering what we have covered, and as you may have noticed, I've swapped roles with Oliver this time, so I'm going to be asking him questions and making sure he's been listening. So Oliver, let's begin with episode 2, the Advanced IC Tester. So in this episode we looked at the Advanced IC Test instrument and the different tests available within that. So what can you tell us about those tests?
So the tests that the Advanced IC Tester can do, there are 5 tests. It starts off doing connections, does a truth table test, then does a voltage test, thermal and VI.
So it's power on first and power off?
Yep, the first 3 are all power on, and then the final 2, they're power off.
Okay, great. What can you tell us about the functional test? How does that work?
So the functional test uses the military standard 0053. It uses our library and it knows how the component should perform if the inputs are driven high, what the output should be driven, and then it drives those, and then it records what the output is and compares that about what it has in front of it.
Perfect. So that was the Advanced IC Tester in episode 2.
Yep.
So in the next episode we looked at the Advanced Graphical Test Generator.
Yep.
So I'll move on into that step using the smart switch.
Okay.
Okay, so in this episode we looked at how we can create our own truth table test. So how does this work, Oliver? How do we set this up?
So you open the graphical test generator, and you usually can find a component already in there. It saves you the trouble. But in some cases, if you want to make your own, you then set how many channels you want to use, and then you do how many patterns you want to choose. It's up to 256 channels per module, so you can have more modules, and then it's 999 patterns along.
Right. So there's a lot of different patterns that you can create.
Yeah, absolutely. 256 and 999, that makes a square grid of 250,000 patterns, and then that makes because they can either be on or off, that makes a combination of 65 billion.
Wow, so that's a really big number. A lot of different combinations that you can use to test your IC or a board level.
Yeah.
Board level test.
Huge functionality.
Right. Great, fantastic. That was episode 3. Okay, in the advanced board checker, we looked at the 2 different test rigs we had during the episode. We had one bed of nails solution. We also had one
energy harvesting.
Energy harvest system, exactly. So what can you tell us about those 2 different solutions and the advanced board checker instrument?
Yes, so in that episode we had a look at those 2 automated solutions, as simple as just putting a PCB in, running the test, and it'll tell you what's wrong. Couldn't be easier. And we had a look at the advanced board checker, which has 64 channels, and for each one of those channels you can choose either 4 states. You can have that pull. So when you turn it off, it's at a set voltage. Most people probably choose 0, but there's an option to choose a higher voltage. We also have drive, which drives that pin at a certain voltage you choose, has a sense, so it senses what that voltage is, kind of like a 64 channel multimeter, and the final state you can choose is a VI test.
Wow, so you could do a complete board level test as well with this. As you mentioned, a large scale digital multimeter as an example. Exactly,
so you could do either 64 points on a single PCB, or maybe you do 32 points on 2 PCBs.
Fantastic, and if you had more modules, more channels, meaning you could do more tests. Right, great. So that was episode 4. In episode 5, we looked at the Advanced IC Identifier. Okay, so in this episode we covered 2 things. First we looked at the Advanced IC Identifier, then we looked at the BDO cable as well. So before we move on to the BDO cable, what can you tell us about IC Identifier itself?
So in this episode we actually used the Advanced IC Tester to make sure that we had those signals coming in and we were isolating those. And then with that, once we isolated the IC, we could then put on the IC Identifier, run the test, and it'll tell us what ICs match that profile.
So it tells us devices that are in the system at a library that work in the same way as the device we have in front of us.
Exactly. So the one we tested then and there was a 7400. It came up with a load of 5 400s to begin with. Would have got to 7400 eventually. And then you can see the description was a 2-input quad NAND gate. So we could tell from that the functionality of that device was a 2-input quad NAND gate.
Perfect. How does this help us with obsolescence management?
So in an industry, some engineers call it a black box. When you get an IC and you don't know what it does, it's just been house coded, such as ABB or Siemens, and you can actually use this to click on there and see how that IC functions and maybe see what the original IC was.
Great. So that was the first part of episode 5. we also covered the BDO cable. So how does that work? How does that allow us to test our ICs?
So we used the BDO cable to isolate that IC that we were testing, such as the IC identifier. We use it in a later episode of the EPROM verifier. And so we use that to disable clock signals or activate any other functionality of that PCB using either the 4 highs or the 4 lows, and you've even got 2 grounds on that cable as well.
Right, so that cable helps us stabilize the IC in order to test it, to do functional tests, truth table and so on.
Exactly, so in that episode we used it to disable the clock signal to pin 2.
Right, that's great. So that was episode 5 where we covered the IC identifier as well as the BDO cable. In episode 6 we covered the short locator. So it's a very simple test, however it can be used in many different ways. So what can you tell us about that?
So we did this episode on the short locator, and we demonstrated the different functionality of such a simple instrument. Yeah. So one case is that you can use it to find the VCC on an IC. If you know the power rail on your PCB, you can go across each one of the pins on an IC and find which one's VCC, and then simultaneously do the same for ground. You can also use it as predictive maintenance. If you can measure the same point ever so often, you can see that slow degradation, and maybe that gets oxidized over time, and then it increases the impedance.
Perfect. So you can, like you just mentioned, you can measure the difference in impedance between a good board and a board that's been in the field for a long time, let's say 10, 20 years.
Exactly.
Right, great. So that was episode 6. In episode 7, we focused on the BFL in this episode. So we put the ATM for the side, and we looked at the board fault locator, more specifically the EPROM verifier. So before we did that, we looked at the IC tester. Why did we do that, Oliver?
Well, we used the digital IC tester because that's part of the BFL module, as well as the EPROM verifier, as well as the BDO cables. So in that one module, we were able to find where the signal was coming from, disable the same signal, and then read the EPROM.
Exactly. So we can also do functional tests for the EPROM, but it takes a bit of time, doesn't it? Because we have many incoming signals, hence why we use the BDO cable to
Absolutely. So like the IC identifier, we can't run any tests on an IC that's moving, so we've got to disable that, and then we'll run the test.
Could we do this test out of circuit as well?
Yes, so with the BFL, we've also, because it's got its own power adapter, we can put that into an out of circuit adapter and then run those tests out of circuit.
Okay, great. So once we checked our connections, checked our inputs, we then disabled those and then moved on to the EPROM verifier itself.
Yeah.
Okay, so how does the EPROM verifier work?
So the EPROM verifier, once we disabled all those incoming signals, we then hook the EPROM verifier on, and then we can either read or verify. So first, we opened up a save file we stored before from say it was from 20 years ago when you first writ that EPROM, and then we compared that against the one we had in front of us.
Right, so we use it to verify that our EPROM, the data matches the one that we saved.
Exactly, and then say that maybe that EPROM has changed, you can then save that again and store that file for your record.
Sometimes you find that on legacy PCBs that the data sometimes corrupts over time, especially when the PCB has been in the field for a long time, and this specific test can help us quickly identify whether the EPROM is at fault or whether we can move on and test other components.
Exactly.
Okay, so in episode 8, the previous episode, we looked at the differences between the BFL and the ATM and how these two modules work hand in hand. So Oliver, what can you tell us about these two modules?
So in the last episode, in conclusion, we found that the ATM was best for those system-wide PCB tests, and then from there we'd find the routes and the areas where we might be suspected, and then we'll go in with the BFL to test those components. And that's how our customers used in their test rigs. For our military customer had that bed of nails, and then we had our energy harvesting customer who did the exact same thing.
Right, perfect, Oliver. That was 10 out of 10. You're definitely listening.
Thank you.
Right, so in the next series, we'll be looking at the AICT module, the analog IC tester, as well as the MIS4, which is a multiple instrument station, and how we can use these two modules, which come with the board method, to do further tests. So stay tuned for that series.